Good afternoon to all my YouTube viewers. In this video, I like to discuss about practice paper 1, which is first part, that means class 11 and 11, and then we'll discuss about class 12 part. Let us start the job. If S is trace and Y is Young modulus of material of a wire of energy stored in the wire per unit volume is. Four choices are here. We know stress means here longitudinal stress. We know that energy stored per unit volume will be half longitudinal stress into longitudinal strain. You can see here sigma into epsilon. Now we know stress by strain is the definition of Young modulus. Now from here epsilon will be sigma by y. If we substitute here, half sigma square by y will come. Here sigma means longitudinal stress, and that is the answer here. Let us see which one matches here. This one. C will be the answer. Half S square by y. S means here sigma. Okay. Next job. A tank full of water has a small hole at its bottom. If 1/4 of the tank is emptied in T1 seconds and the remaining 3/4 of the tank is emptied in T2 seconds, then ratio of T1 by T2. There are 4 choices we have to solve. Now you see, say this is a tank. This cross section area of this tank is capital A, and here is a hole, and this hole has area small a, and we know that by using Bernoulli's theorem we can find out velocity of liquid which is coming out, that is root under twice gh. According to height will be the variable here, root under twice gh. Now let us say this liquid has come down to this height. X is the height from from base to this distance is x. Therefore, velocity at this point, the top level liquid will come down with dx by dt. Now we know from equation of continuity, velocity here into area will give velocity here into area, the liquid which is coming out. That means A into dx by dt, we can write area, small a area of the hole into velocity here, that will be root under twice gx. This relation is important. Now here a is constant, twice g is constant. Now x is only root under x will be the variable here. So rearrange them, you will get dx by dt. We can write in this fashion: small a root under twice small g divided by capital A root under x. We can take this one constant. Say k is constant here. You can see k is constant into root under x, where k means this one. Now rearranging, you bring down the root under x here, and you will get dx divided by root under x. Integration of this one will give dt will come this side, that is k dt, 0 to t1 time according to question. How much it will level will come down? Level will come down by 1/4. That means from here initial height is small h, then it will be 3/4 h. That means limit will be done accordingly. Initial position when time is 0, height is h. When time is t1, height is thrice h by 4. That is the condition given in the first condition. From here, if we integrate, we will get this type of expression. That is 2 root x to the power half will come. Lower limit is small h, upper limit thrice h by 4, equal to k into t1. because this integration will k into t1 minus 0, that means k into t1. So this is one of the equation available here, that is 2. After putting this limit we can get the final expression will be like this, that is this one, thrice h by 4 whole to the power half minus root under h will come, then take out h, will get express, will take care of it when we will do the ratio. Then we have to similar equation, same equation, just limit to be changed. Now 3h by 4 will be, now again time starts from the second condition, that is time 0 to t2, that means the initial height will be here 3h by 4 to finally 0 level of liquid, I mean total vessel is emptied out. Now after integration of this one, 2x to the power half, limit accordingly given here 3h by 4 to 0, and that will be kt2. Now dividing these two we can get finally we can get t1 by t2 will be this one, that is 2 minus root 3 divided by root 3 will come. You simplify little bit here, you just put data, expressions are available, take common and simplify, and you will get 2 minus root 3 divided by root 3, that will come. Now the same job, you can see that this type of expression came, h2 thrice h by 4, that 41, and 42 2x to the power half and thrice h by 4 to 0, that was the limit. Now 2 will get cancelled, further simplified in this form, and this will come, then substitute limits and you will get t1 by t2 will be 2 minus root 3 divided by root 3. Okay. Now next job, a square plate of side L has mass big M. What is its moment of inertia about one of its diagonal? You can see here, this is the square plate. We have to find out any one of the diagonals moment of inertia. That means this is a square plate, moment of inertia with respect to center of mass perpendicular to the area will be 1 by 6 ml square. This is to be known before solving this problem, ml square by 6, otherwise you cannot solve. I mean it will pass with respect to IZZ axis. Now from perpendicular axis theorem, sum of these two axes, that means I13 equal to I12 equal to I34, because they are perpendicular to each other. Sum of these two will give the ZZ axis, that means this value ml square by 6. Now these two are symmetric, so they are equal. So that means sum of these two means twice of I12 equal to ml square by 6, and only I12 will be divided by 2, that means it will be 12 here. And that means ml square by 12 will be the answer with moment of inertia taken with respect to any one of the diagonal. That answer B will be the correct one. B will be the correct one, you can see here. Now the next job number 4. A system of springs with their spring constants are as shown in the figure. The frequency of the oscillation of the mass m will be assumed that the springs are massless. Now you can see here 4 springs are there. These two parallel, these two series. After finding equivalent spring constant of the parallel springs, then all 3 will be in series. That means we can use this type of equivalent calculation, that is 1 by k equivalent is the spring 3 and 4 parallel, so there will be sum of the two will be the equivalent. That means after that 3 springs will be there, then all 3 will be in parallel, in series. So 1 by K3 plus K4 plus 1 by K2 plus 1 by K1 will give the equivalent 1 by K equivalent. That is the basic relation for parallel for series equivalent formula. Once K equivalent is available, then we can K equivalent simply you can simplify and you can get, and that means time period equal to, you know, T equal to 2 pi root under m by K equivalent. Now we need frequency, that means 1 by T. Our final expression will be this one, 1 by 2 pi root under K equivalent by m. If we substitute, we will get the correct choice. That means choice C will be the correct one. You can check it. This is a simple job. Next is job number 5. A closed organ pipe and an open organ pipe of same length produce 2 beats per second. When they are set into vibration together in fundamental mode, the length of open pipe is now halved and that of the closed pipe is double. The number of beats produced will be, I mean there are two conditions. First condition, one is open pipe, another is both end open, another is one end closed pipe, and fundamental frequencies are known. Here you can see that fundamental frequencies for one end closed is V by 4L, for both end open V by twice L. Now this is double of this frequency, so this one minus this one will give the bit frequency N1 minus N2. Here N1 is this one, N2 is this one. Fundamental frequencies here, so that is 2 given in the question. Second condition given, that both end open pipe has been reduced to 50%. I mean V by 2 within bracket L by 2, and that one end closed tube has been increased to double. I mean V by 4, that length has become twice L. After simplification we will get V by L 7 by 8 will come, and from here, from the first equation we can get V by L, and that V by L we can substitute here, that V by L will be 8. You substitute here, you can see V by L has come 8. Substitute here, you can get 7 hertz. That means bit frequency will be 7 hertz. Now next job. A force of 7I plus 6K Newton makes a body move on a rough plane with a velocity 3J plus 4K meter per second. The power in what is? We know power expression, power equal to, we can write down force dot velocity dot product. Now all this given, force given, velocity is given, so simply you have to do dot product here to get all given in terms of SI unit. So no problem. 7I plus 4K dot 3J plus 4K. Now I dot J will be 0, you know that, and then I dot K also 0. Then that means 6K and 4K will survive. That means 24 unit will be there. 24 watts will be the power of the. Now come to job number 7. Here you can see 3 samples of same gas A, B, C, same gas, comma given 3 by 2, have equal volume initially. Initial volume same. Now the volume of each sample is double. For A, the process is adiabatic. For B, it is isobaric, I mean pressure constant, and for C, process is isothermal, temperature constant. If the final pressure are equal, final pressures are equal for all the 3 gases, 3 samples, the ratio of their initial pressures we have to find out, and then the ratio will be taken. Now this job is simple. What you can do, you can start in this way. Let us say we know adiabatic process. Here first one has given in adiabatic process. Process is known P1 V1 to the power gamma equal to P2 V to the power gamma. We are interested about P initial pressure. So initial pressure is PA divided by 2 to the power gamma, because you know P1 PA V equal to P final pressure into that final pressure is same as it is given in the question. Final pressure say PF, that will be how much? Now V to the twice V to the power gamma. So VP will cancel, V to the power gamma, V to the power gamma will cancel, 2 to the power gamma will left. So this will come PA by 2 to the power gamma. Similarly for isobaric, no change in pressure, so it will remain same. 1 will be here. For isothermal expansion, where temperature P1 V1 equal to P2 V2, in this expression only 2 will come. The final pressure is this one. That means final pressure for first gas, second gas, third gas are available, that is PF. And from here we can understand that if PA is available, take some constant here, this one PF. Now final pressure. Now 2 to the power, this one will come next. PV is available, that is P2, PF will be there, and PC is available, and take their ratios. It will be 2 to the power gamma PF, and then P suffix F, then ratio to PF. I mean 2 to the power gamma PF is to PF is to 2 to the power 2 PF. PF removed from all, you will get expression this one. This will be the answer for final pressure. That means 2 to the power 3 by 2, what it means? 2 root 2 will be there. 2 root 2. Here it will be 2 root 2. 1 is 1, 2 is 2. This will be the answer. B is the choice here. Now you can see. You can see B is the correct one. Next come to next job. The temperature of equal mass of 3 different liquids A, B, C, 12 degree, then 19 degrees Celsius, then 28 degrees Celsius respectively. The temperature when AB are mixed 16 degrees Celsius and BC is 23 and so on. And we have to find out when A and C mixed what is the temperature. Now for this specific heats are not given here. What to do? We have to take like this, heat gain equal to heat loss, we know the basic energy balance formula, that is heat gain equal to heat loss. Heat, the temperature here is 12 degree, it will gain to some higher temperature T for the sample A. That means mass specific heat, this is the difference, T minus 12 equal to mass specific heat. Masses are same given in the question. SB 19 minus T. From here SA by SB will be available 3 by 4. Similarly, for the next equation, B and C, between B and C, we'll get 23 minus 19, and here 28 minus 23. Final temperature is 23. Here is given SB by SC is available. So, take ratio of SA, SB and SC altogether. You will get 15 is to 20 is to 16. This is a simple mathematics. Now, from here we require SA and SC, first one and last one, 15 is to 16, that is required, because here we have to find out T dash, which is unknown here. SA T dash minus 12, you already given that the initial temperature of sample A is 12, then final temperature T dash, and here it is MSC. Final temperature 28, highest temperature minus T dash. Then solving T for T dash, we require to simplify here 20.26 degrees Celsius will come, answer will be C. You can see here answer is there, C is answer 20.2. Now come to next job. There is a plot. A transverse wave is traveling along a string from left to right. The figure below represents the shape of the string at a given instant. At this instant, among the following, who choose the wrong statement. You have to find out wrong statement. Now in this diagram, you have to see this is position is a mean position for the string. This is also mean position. This is the extreme position. This is the extreme position. Extreme position velocities are minimum, I mean 0. Here is maximum. Let us see what are the choices given here. Point D, E, F have upward positive velocities. D, E, F. You can see in this diagram, of course, D, E, F. You can see D, E, F. Wave is traveling this side, so this will rise. D also rise. D, E, F. F as it is going this side wave, so this will rise. All 3 points will rise. It is correct. Now come to next statement. A, B and H have downward negative velocity. A, B, H. A, B and H. Yes, that is also correct. You can see A, B, H. You can see A here. As it will travel, a strap will come. So A will come down. B will come down because this portion will come down, entire particle. Now F is here. This will go up. A, B, H. I think it is asked about A, B, H. H will come down. You can see here this H point, as it travels this side, this will come down further. Now this point also correct. Point C and G have 0 velocity. C and G, of course, C and G has 0 velocity. This is also correct. The point A, E have minimum velocity. No. A and E have maximum velocity. You can see A is the mean position, A has maximum velocity. So D will be the correct choice here. Next job, the ratio of the energy required to raise a satellite up to a height small h above the earth of radius bigger in the to that the kinetic energy of the satellite into that orbit is. 4 choices are here. We have to see what is the question. The ratio of the energy required to raise a satellite up to a height h. How much kinetic energy is required to raise height small h? Above the surface, above the earth of radius r. To that the kinetic energy of the satellite into the orbit. I mean that satellite will rotate in a circular path around the earth. In that case, what is the kinetic energy? These 2 ratios is required. Now when it is on the earth's surface, it has only potential energy, this one, minus Gmm by r. It has to give kinetic energy to lift up. Say it has gone up h height. So what will happen? It will have energy to h height, that is minus Gmm. That is the minimum requirement. That is r plus h will be there. R plus h will be there. So find out half mv square. That is bring this one right side and solve. We will get this type of expression. G big M small m h by r within bracket r plus h. Now this is kinetic energy to be given to the satellite to reach at that particular height. Now we know that as it will rotate in a circular path, its necessary centripetal force will be given by gravity force, that is Gmm. G big M small m by r plus h whole square, that is centripetal acceleration, centripetal force is mass into velocity square by r plus h. Solving here mv v dash square will be G big M small m by r plus h will come. Now just multiply half both the sides. That will be the energy when it is in the circular path, that mass energy, kinetic energy is there. That is G big M small m by 2 R plus H. We have to find out ratio between the input energy initially, that energy given, that is E, and this energy. Ratio between these two is being asked, E dash. And solving here we can get small 2 small h by big R will come. You can see 2 small m 2 it will be 2 small h by bigger, 2 small h by bigger. That means D is the answer here. D is the answer. You can see here. Now we'll discuss about part B, that is 12 part. 10 questions from this area. Let us see first question. The phenomenon used in optical fiber for transmission of light energy. Which phenomenon is used? The total internal reflection, scattering, diffraction, refraction, that you know the total internal reflection, TIR is required. Now come to next question. The uniform magnetic field of 1000 Gauss is established along the positive z direction. A rectangular loop of sides 10 centimeter and 5 centimeter carries a current 12 ampere. What is the torque on the loop as shown in the figure? You can see this figure, current is anti-clockwise. This loop is placed anti-clockwise. Its area vector will be along the direction of z, and magnetic field also in the direction of B. So angle between area vector and B both is same direction, so 0. Now torque is torque equal to I A cross B. Area vector cross B vector. So it will give you cos sine 0. Cross product will come sine. That means both acts in the same direction. So it will be torque will be 0 here. Torque perpendicular to the area vector, and current carrying loop upward direction, that is K direction. So torque will be A I cap cross B I cap will be 0. 0 will be the answer for this one, first one, A. Now come to the length of a telescope is 36 centimeter. The focal length of its lens can be. We have to see all possibilities here. We know that a length equal to FO plus FE. FO plus FE. Now objective focal length and eyepiece focal length, and all these two lenses converging. Now here you can see converging is only in A. 30 centimeter plus 6 centimeter, it is 30 plus 6, that means 36 centimeter. A can be the answer. A is the answer here. Now come to next job, that is here. A wire A, B, C, D, E, F, each side length L, bent as shown in the figure. The wire carrying a current I is placed in a uniform magnetic field B parallel to the positive Y direction. Positive Y direction, magnetic field along positive Y direction. You can see positive Y direction means this is origin, X this side, Y right side, perpendicular to the Z side. That means the force experienced by the wire in the Z direction. Force you can see for this wire, what will be the direction of force? It is parallel to Y, anti-parallel to Y, so force cannot be there. I L cross B, that is 0. This is also 0. This which is coming out, I think this is going in, and that is this is entry. In this way current is. Now for this portion of the wire it is coming down, and this one upward, so they will cancel. These forces will cancel. Now find out for DC. DC current along X axis, that means I, and B is along Y axis, and that means J, I cross J, it will be K. Direction of force will be along K direction. Yes, that is possible, BIL will come, because this length is L. L cross B means here I cross J will come, that is K. I mean it will give you answer C. BIL. Answer C will be there. Okay. Now come to next job. Now here. Question is, a straight wire carrying current I is turned into a circular loop. If the magnitude of magnetic moment associated with is M, the length of the wire will be, you have to find out length. I mean L equal to 2 pi r, because it will convert to circular loop. L equal to, you can write 2 pi r, r will be L by 2 pi, and magnetic moment is simple I into area vector. Moment direction will be according to the direction of area vector. Now this M will be I, and area means pi r square, and r is already known, that is L divided by 2 pi. The expression will come I L square by 4 pi. We need to get L, so cross multiply, that means root under 4 pi big M by I will be the length of the wire in terms of magnetic moment and current. That means choice number B, you can see answer here. Now next job, that is 6. In a circuit, LCR circuit, the voltage across the resistance, capacitance and inductance is 10 volt each. If the capacitance is short circuited, the voltage across the inductance will be. I mean in LCR circuit, potential drop across the resistor is 10 volt, potential drop across the inductor is 10 volt, and potential drop across the capacitor is 10 volt. That means I into R equal to 10 volt, I into XL equal to 10 volt, I into XC means reactance, capacitive reactance, that will give you 10 volt. Now from here we can say R equal to XL equal to XC, as it is potential drop given 10 volt given, and that means this one equal to this one equal to this one, so remove I, and then R equal to XL equal to XC. This is important relation here. Now next, when capacitor is short circuited, the impedance will become impedance will be root under R square plus XL square. I mean XL can be replaced by R as relation is available. XL replaced by R, that means 2R square will be root under 2R square, then take out R, that means root 2R will come, that means supply voltage 10 and root 2R. Bring this current is I dash after capacitor is short circuited, then I dash R will be the present potential drop across the inductor, because it will be equal as it is being given here, that is R is same, that means potential drop will be across the resistor I dash R, and for inductor also I dash XL, because R equal to XL, so this will become V dash L, I mean potential drop across the inductor, that will be 10 by root 2. Now next job, an electron of mass small m when accelerated through a potential difference V has de Broglie's wavelength lambda. The de Broglie's wavelength associated with a proton of mass capital M accelerated through the same potential difference will be. we have to find out wavelength for this particular for proton when it will follow de Broglie's wavelength. Now we can write here that kinetic energy, we know that half mv square expression, that kinetic energy will be the charge into potential drop. The potential drop is given here. Charge is electron means small e into V is the potential drop. This is capital V. And here kinetic energy will be E into capital V. That means half mv square. You can convert this one in terms of momentum by multiplying one small m here on both the sides. Now this will become P square. P square will be how much? 2 times small m, small e, capital V. That means P will be root under this one, root under twice small m, small e, V. Okay. Now we know that from de Broglie's equation we know that wavelength for electron will be h by momentum of electron, that will be h by, already we got root under twice small m, small e, big V, capital V here. Similarly, for proton will be h by momentum of proton. Here only thing will change, that is small m, instead of small m, big M will come, because it is proton. We are talking about proton here. H by root under twice big M, small e. Charge is same, proton and electron, and big V. Now take the ratio of proton by electron. Proton wavelength divided by electron wavelength, this ratio will come. Then this after simplification we can get root under small m by big M will come, and that means proton wavelength for proton will be lambda electron root under small m by big M, lambda electron nothing but lambda, which is given in the question, root under small m by m. That means this will be the answer for this particular job. Now see here, I think B will be the answer, this one. B will be the answer here. Now next job, a logic gate circuit is given here. We know that this is a NOR gate given same input. When NOR gate is given same input, it will become NOT gate. Suppose both is 0, it will give output 1. Output will be this one, that is y equal to A bar. A is 0. If you give 0 here at A, both is 0, so output will be 1. Y will be 1, output will be 1. That means this is NOR gate. Now this NOR gate acts as a OR gate. OR gate means whatever you give, opposite comes. If you give 1, it will give 0. Now what is, we have to see this 4 NOR gate arranged in such a way, what is the truth table available at the end, at the output at y, that is to be checked here. Now we can have a truth table like this: A, B, y1, y2, y3 and then y. Here if you see this diagram, A, B, y1, y2, y3 and then y. Now if A is say 0, B is also 0, both will be 0 here, because both are 0 input. Now output will be 1. Here also if 0 given, output is 1. y1 and y2 both will be 1. You see 1. Then here another NOR gate is given. So both 1 means output will be again 0. So y3 will be 0. Then another NOR gate, so output will be 1 here. That means both 0 means output 1. When 1 and 0, let us check. 1 and 0, output here is 0, here is 1. Again sum of this 1, 0 will be the output. Once 0 output here, both are 0, that means output will be 1. So 1 0 also 1, 0 1 also 1 will be coming, output will be 1 only. When 1 1 given, then you will see this will give 0, y1 0, y2 0, and y3 will be 1. When it is 1, then it is output is 0. This is a very specific gate available, that is called NAND gate. The truth table of NAND gate, we have to know that all outputs are 1, only when both inputs are 1, then it is 0, output is 0. That is NAND gate. So ultimately we got NAND gate out of it. So we have to find out which gate belongs to this arrangement. Now here you can see NAND gate is D. D is the choice here. Now come to next job. That is a critical angle of a certain medium is sine inverse 3 by 5. The polarizing angle of the medium is, we have to see polarizing angle. How to do? I think this is the choices. These are the choices given here. We'll check. Now for this job, theta c is given, critical angle sine inverse 3 by 5. Now we know the basic, by using Snell's law, you can write dense medium to rare medium, you have to go mu sine of theta c equal to 1 into sine 90 degree. From here we know that sine theta c will be 1 by mu, and here given that sine theta c is 3 by 5, that means it will be 5 by 3, mu will be 5 by 3, dense medium refractive index will be 5 by 3. Now from Brewster's law we know that tan polarizing angle, that is theta p, is how much? Equal to mu, and mu here 5 by 3, so we can write 5 by 3 here. Brewster's angle, that is tan theta, that is given here, tan theta p polarizing angle, this angle is called polarizing angle, this one, and this is refracted, this is partially polarized, this is plane polarized light, this is partially polarized. You can see dot means into, cross means, that means it is unpolarized light, and here also partially polarized. Intensity, this magnitude will reduce slightly, but here you can see that cross part is over, only dot part is there, that means it is going in a particular direction is allowed, that means plane polarized. Now here it is tan theta p will be mu. Now put mu 5 by 3, theta p will come, polarizing angle will be tan inverse 5 by 3. That will be the answer for this job. That is this one, 5 by 3. B is the answer. It will be B. Okay. Now come to next job. Now this one already we did in earlier videos, that is K1 and K2 are maximum kinetic energies of photoelectrons emitted when light of wavelengths lambda 1 lambda 2 respectively incident on a metallic surface. Lambda 1 is 3 times lambda 2. What it means? Lambda 1 is 3 times lambda 2, that means in terms of energy it will be just opposite. Lambda 2 will hold energy, it will contain energy 3 times energy of lambda 1. If lambda 1 has energy E, it will have thrice E. That is the thing available from here. Now from here, incident energy for lambda 2 will be 3 times E. If for lambda 1 it is only E. Now we know that maximum kinetic energy, let us talk in terms of kinetic energy. This is stopping potential electron, that is not required here. Maximum kinetic energy equal to incident energy minus work function, because it is a same substance, photoelectric substance is same here. Metallic surface, on a metallic surface, a particular metallic surface, we are talking about. Now that means it will give us k1 equal to E minus W for the lambda 1 wavelength, and for k2 will be 3 times E minus W. W will be same for, because same material is there, work function is same. So substitute this one here, substitute E from here, you will get this type of expression, that is 3 times k1 plus W, 3 times k1 plus W minus W. That means if you simplify here, you can see that k2 is greater than 3 times W, k1, 3 times k1 plus W, twice W2 will be there. So from here we can say k1 will be greater than, this is mistake here, k1 will be less than k2 by 3. Now you can see here k2 is greater than thrice k1, that means k1 will be less than k2 by 3. That is the point you have to say. Answer will be, for this particular job, answer will be this one, B. K1 is less than K2 by 3. This will be the answer. Now thank you very much for good listening. Let us practice, and now you can speed up your process. Already you have done so many problems, now you can speed up. Because you can see how, in what manner you can handle the problem, what are the things to be remembered well before, so that in exam hall you need not to think much. Just you put that equation, and your target to mark the correct answer, is it not? Just you take the suitable position, that whatever equation or whatever relations are giving better, you can save time. You have to check in that way, and I think this way we can speed our process. We have done 20 questions from 10 questions from part A and 10 questions from part B, and in this way we will proceed few more videos, and every video will give you lot of motivation. Thank you very much to all of you.